All right, guys, so for these problems, the steps are written on the sideboard over there, right? The first thing you're going to do is you're going to factor. So when I factor this one, on the top I get x plus 4, x minus 2, and on the bottom I get x plus 1, x minus 2. After you factor, you should immediately state the domain restrictions from the denominator and then do the domain. So from the denominator here, x can't be negative 1 or positive 2. So applying that to my domain, I get this 3-interval domain. All right, after we factor, after we find the domain, then we do the whole. Because if you do the whole first, you're going to miss part of the domain. Okay, so the whole happens when something cancels out. In this problem, what cancels out is that 2, right, the negative 2. And so I rewrite the equation without that x minus 2. So you'll see I've got x plus 4 over x plus 1. The whole is happening at positive 2, the restriction of that canceled out factor. So I plug 2 into that equation, and so my whole is 2 comma 2. All right. From there, I can do my vertical asymptote. So if x can't be 2 is the whole, then the negative 1 restriction is my asymptote. All right, so that's x equals negative 1. Normally, we would think that both of those are asymptotes, and they usually are. The only time they're not both asymptote is if one cancels out. And that doesn't happen a lot, but I made it happen a lot the past few days, so you practiced with it, but it doesn't happen that often. All right, and then for HASA, I'm looking at the powers in the beginning of the problem. So my x squared over my x squared cancels out and just leaves me with a 1. So my horizontal asymptote is 1, which means I don't have a slant. You either have one or the other. And then my horizontal asymptote is what determines that end behavior. So my end behavior is 1. What does that look like on a graph? Does your paper have a graph on it? Yeah. All right, I want you to start getting used to plotting those things, because a lot of those things don't show up on the graph, but I want you to be able to tell where they're at. So x equals negative 1 is a vertical line. X equals is a vertical line at negative 1. Y equals 1 is a horizontal line, and a whole is just an open circle. Okay? So basically at this point, that's all you can get from this graph. Some of you will be able to figure out what this looks like. And if you can't, all you have to do is type this equation into your calculator and let your calculator graph it for you. So your calculator is going to show you. It gets close to this asymptote and just kind of comes down, and then it takes a brief pause here. You're not going to see that pause because it's so small. But graphing it, you'll know it's there. And then it'll keep continuing on this way. And normally when there's something up there, it's always the opposite side. Not always, but most of the time it is. So if you don't want to guess, then just type it in your calculator and check. But that's what this graph would look like as a sketch. All right, so that's what we've been practicing the past few days in class. Anybody have questions on those? Today we're going to add in 2 new words, x-intercept and y-intercept. I'm going to show you how to do this by hand, which in my opinion is the faster way. But I will show you how to do it in your calculator as well. So just in case you don't want one more thing to memorize. Like, your calculator will do the work for you. In my opinion, it takes longer to do in your calculator because you've got to type a whole equation in. You've got to trace it. You've got to go above and below. But it is an alternative to memorizing any more rules. All right? So in your toolkit, part 4 says x and y intercepts. Are they numbered? No. Let me just say that. Here, part 4. Part 4. It says part 4 at the top. Now, here's what you have to think about. An x-intercept intercepts the x-axis, right? So an x-intercept happens on the x-axis. Every single point on an x-axis, no matter where it's at. So, like, if this is my x-axis, this point here, this point here, this point here, they're all x-intercepts. And they all have one thing in common. If they're landing on the x-axis, then the y value is 0, right? They have different x values based on their location, but the height of them are all at 0. So something to know about an x-intercept is no matter what you do, an x-intercept always has a y value of 0. So you can see in the formatting of an x-intercept, it's some number, comma, 0, always. So if I'm figuring out an x-intercept, I just need the x value. The y value will be 0. So how do I figure out the x value? Well, if I want the y value to be 0, then I want the whole equation to equal 0. So I have to figure out, what do I got to do to make this whole equation equal 0? If I make the denominator equal to 0, the whole equation becomes an error. But if I make the numerator equal to 0, like if I end up with something like 0/5, then the whole fraction becomes 0, right? So in order to make an equation zero out, you're setting the numerator equal to 0. A restriction makes the denominator an error. A numerator error makes the whole equation just become 0. So numerically, to find an x-intercept, you set the numerator equal to 0. So I'm going to take whatever's in the top. Sometimes I might have to factor it. In this case, I don't. I'm taking the top, and I'm setting it equal to 0. It looks like it might be a vertical asymptote, right? Because it's kind of the same format, but it's not. Putting 1 into this equation, the top's going to become 0. So 1 minus 1 over 1 squared minus 9. 0 over 1 minus 9. 0 over negative 8. It's just creating this 0 for the entire equation. So again, you have to remember that an x-intercept is a coordinate point, not an equation. You're finding the x value. The y value of an x-intercept is always on the x-axis, so it's always 0. The x-intercept is 1. Now, let's say 1, that doesn't make sense to you. Or 2, you're going to forget that because at the end of the day, there's a lot of steps to these problems. This is one more thing you have to memorize. If you don't want to memorize it, you can use your calculator. So what you do to do this in your calculator is type the equation into your y equals screen, which you're ultimately going to have to do anyway if you want to get the shape of the graph. So the top was x minus 1, was the bottom x squared minus 9. All right, so I've got the equation in my calculator and I hit graph. You can do this in your calculator if you understand what an x-intercept is. An x-intercept is happening on the x-axis. So to trace an x-intercept in your calculator, you can do a second trace like we do when we're finding a min or max. But instead, which one do you think we'd pick? 0, right? We're trying to find the 0. So you could do a second trace 0. And I don't see, like this is an asymptote, so it's not going to hit that line. My x-intercept isn't hitting here. It's when it crosses over the x. So you'll see it kind of go top, bottom, or cross over it. So I want to trace this point. So I go to the left of it and to the right of it. You just want to make sure, like if you're not quite sure what the left and right are, look here. You want a positive number here and then a negative, so you're clearly crossing over. And then one more, and it gives me the same thing I got when I solved it by hand. Okay, so you can trace an x-intercept in the calculator, or you can solve it by hand. Solving it by hand is setting the numerator equal to 0. I think that's faster. But again, it's just one more thing that you have to memorize.
Is x-intercept where it intercepts with the x-axis?
With the x-axis.
So would y always be 0?
Yes, yes.
So y 0 every time?
Every time. So in the formatting, it's always, you can say, blank, comma, 0. So it's a coordinate point where y is 0. All right, so in this case, it's 1. We traced it in the calculator, and we solved it by hand. Okay? Another thing you're going to find is a y-intercept. So a y-intercept happens on the y-axis. Every point on the y-axis, no matter what I do to it, is going to have a different y value, but the x value will always be 0. Okay? So to find a y-intercept, you're going to put x is 0 for all of the x's. You can do that in factored form, or you can do that in standard form. It doesn't matter. So like, you know how we usually factor at the beginning of the problem? You can plug zeros into that form, or you can plug it into the original form. So when I'm finding a y-intercept, I'm taking this equation and I'm putting 0 in the x spot everywhere that there's an x. All right, everywhere I see an x, I'm going to put 0 in. I'm going to do it over here so I can remember. So 0 minus 1 over 0 squared minus 9. And what's true about a y-intercept is no matter what, it has an x value of 0. So my y-intercept is 0, 1/9. If that feels like one more thing to memorize, you can do this in your calculator, okay? So to find an x-intercept in your calculator, you trace it. But to find a y-intercept in your calculator, you just have to go to your table. Go to x is 0 and see what's next to it. A y-intercept in your calculator is a lot quicker. So if I wanted to do this in my calculator, I already have the equation in. I go to the table and I look at 0 and what's next to it. That's my y-intercept. If you have an error next to your 0, then that means there isn't a y-intercept, because that could happen too, okay? So we can do it by hand by plugging 0 into our equation, or we can do it in the calculator by looking at the table. So what these things look like on my graph is an x-intercept happens, I know you don't have the graph, an x-intercept happens on the x-axis, and a y-intercept happens on the y-axis. So this would be like here. It gets us like even a little closer to making that sketch more accurate. Because now I'll know, okay, it goes through the hole, but now I have another point it goes through too. So it just makes it more accurate.
Do you define the y-intercepts? Do you put the zeros in before or after you factor?
Your choice. You could do, I like it before. I think it's easier, but some kids find the factor form easier. So I think it's just a preference.
Okay.
You can factor it and plug 0 in there, or you can plug it into the original. All right, so let's look at this next one. This next one you probably would have factored from the start, right? Because step 1 is to factor. So if you factored it, you could do this in factored form. Finding the x-intercept is setting the numerator equal to 0. So in this case, factoring it is going to help me with that a little bit more. So if I were to factor this numerator, I'd have -5, +2, right, like here's factored form. So say we're working from factored form. The x-intercept happens when the numerator equals 0. Because if the numerator equals 0, the whole equation becomes 0. So the y value ultimately ends up as 0. So to find the x-intercept, I can set each numerator equal to 0. In this case, there's 2 x-intercepts. 5, 0, and -2, 0. Or, alternatively, you could do this in your calculator. X squared minus 3x minus 10. 2x squared plus 6x. So here's my equation. If I want the x-intercept, I know that I'm tracing where this graph intersects the x-axis. It's not happening over here. You can see there's like a gap, right? There's definitely one right here. I can read it pretty clearly in the graph. But if you're not quite sure, you can do a second trace 0. And I'm just going to either side. So I want to make sure like my cursor is below it. I'm looking at negative values. And then above it, I'm looking at positive values. So that happens, right? -2. And then I can see that this line crosses over the x. See how you can see a little bit of black underneath it? So something's definitely happening over there too. So I can trace this one too. I just got to make sure that it crosses over, so my x values have to become positive at some point. And there's my 5, 0. So we can trace it in the calculator, or we can solve it by hand. Your choice. Y-intercepts happen on the y-axis, so you can plug 0 in for all of the x's. You can do that to factored form. 0 minus 5, 0 plus 2, 2 times 0, 0 plus 3. Or you can plug it into the original. 0 squared minus 3 times 0 minus 10 over 2 times 0 squared plus 6 times 0. You ultimately end up with negative 10 over 0. And if you type that in your calculator, you're going to get an error, which means that this graph does not cross the y-axis. What do you think it means if the graph doesn't cross the y-axis? Why wouldn't a graph cross the y-axis? There's an asymptote there. Very good. Yep. If there's an asymptote at 0, it's not going to cross it. So this means that there was an asymptote at 0, and that's not why it's not crossing it. If that doesn't make sense to you, use your calculator. Your y-intercept's going to happen in your table at 0. You can see in my table at 0 I have an error. So that's why I don't have one. Okay, so you can use your calculator or the equation. So for this one, there would be 2 x-intercepts, one here and one here, and no points on the y-axis. If you could, I changed this last one. I wanted to have one that had a hole in it, so you could see like the effects of a hole on these things, and none of the examples in your toolkit had one. So I changed this example. It's different than the one in your toolkit. X squared plus 2x minus 35, x squared minus 4x minus 5. So if we factor this, I'm just going to factor it up here. I got x plus 7, x minus 5, x plus 1, x minus 5. So let's just think about what a hole means. A hole is this imaginary point on the graph, right? So we're going to have a hole at negative 5. So if it's an imaginary point on the graph, then it can't be an x or a y-intercept because you're not going to see it. You see an x and a y-intercept. It's when the graph physically hits the axis. So when you have a hole, even though it's going to look like it might be an x-intercept, it's not, okay? So these cancel out. So when I'm going to find the x-intercept and I'm setting the numerator equal to 0, I'm only going to set this factor equal to 0. This graph's only going to cross at negative 7. Now, if you prefer to do this in your calculator, the hole won't matter because you're not going to see it. So if you're tracing the 0 in your calculator, it won't. You'll just only see 1 and you'll just trace the 1. So a hole is a hole. It's not a vertical asymptote. It's not an intercept. It only goes in the hole blank. So if something cancels, it will only go in the hole blank. In terms of the y-intercept, I'm going to plug 0 in. You can plug 0 into the original equation or the canceled out equation. You're going to get the same value either way. I'm going to do 0 squared plus 2 times 0 minus 35. Over 0 squared minus 4 times 0 minus 5. I'd get 7. If I plug it up here, 0 plus 7 over 0 plus 1, 7 over 1, I still get 7. If you're doing it in your calculator, you're just going to when x is 0 to see what y is. You can trace it that way. All right, so on this one, we're going to have a y-intercept at 7. And an x-intercept somewhere over here at negative 7, which is just going to make the graph even more accurate. That's the new stuff for the day. I just want to make sure you can do those things so you can apply those skills. So on page 7, 17 through 22 is all the new stuff. There's vertical asymptotes, there's horizontal asymptotes, there's slant asymptotes. There's, what else was new? Holes, sometimes. And then x and y intercepts. So you're just practicing those concepts. I don't know that you'll get through all of that in 12 minutes, but I'm thinking get through what you can, and then we'll go over what you did in that time. So this is in your workbook, this one.
What's the answer to
I'm going to go over it. I'm always going to post the K. I'm not going to go over every step. So 12 minutes puts us just after 11. Equal to 0, right? So like what can't x be? X can't be 1, because if the denominator's 1, then this becomes a 0 and everything's in error. So my domain is that x cannot be 1. So when I write my domain, I'll write everything except for 1. If x can't be 2 things, then you have like 3 intervals for this. All right, so factors, state the restriction, cancel out matching factors. In that case, you have a hole, but I don't have one here. So for the blank for the hole, I'm going to write NA. Nothing canceled out. And then find the vertical asymptote by setting the denominator equal to 0. So I'm going to do x minus 1 equal to 0. X equals 1. So on my graph, at 1, this is what my vertical asymptote looks like. From there, I go horizontal asymptote. So 5x over 3x. Those are the highest powers. And the x's cancel out. So this is a horizontal asymptote of 5/3, which is like 1.66667. So when I'm going to draw this one, again, if we have a horizontal asymptote, we don't have a slant. So if going to draw this one, I'm going to estimate it between 1 and 2. I'm not going to know the exact spot for it, but it's somewhere in here. It's not quite 2 yet. If you have a horizontal asymptote, then you don't have a slant. If you have a horizontal asymptote, then you have your end behavior too. My graph's going to level off at 5/3 or 1.67, however you want to write that one. So far visually, this is what I've got. And I have this idea that it's going to be like this or this, and the x and the y intercept's going to help me figure out which quadrants is it going to happen in. Okay, so for my x-intercept, it's setting the numerator equal to 0. I'm going to set this factor equal to 0. If you're not comfortable doing it that way, you would have to type this in your calculator and trace the 0. But this is going to have an x-intercept at -4, 0. And for the y-intercept, I like to use the original problem, but you can use factored form too. I like to plug it into standard form. Or you can type it in your equation, and you can figure it out that way. So this is in between -6 and -7, right? It's some decimal in between those. So now I know, without typing it in my calculator, exactly which of these 4 regions this graph's going to happen in. It's definitely going to happen down here because it has to go through those intercepts. And so I can get a pretty accurate sketch of this graph without using the calculator. So it's going to be really close to this because its end behavior gets close to that. It's going to go through that intercept. It's going to go through that intercept, and it's going to be really close to that. And if something's happening down there, something's usually happening up here too. So I can kind of get an idea of what it's going to look like. I didn't use a calculator at all. You can, okay? You can use a calculator and get that sketch. But the x and y intercepts, the reason I wanted you to see this is the x and the y intercepts have absolutely no impact on the important stuff. It doesn't help me with the domain. It doesn't help me with the range. It doesn't help me with the end behavior. It doesn't help me with the mins or maxes. It just gives me this accurate sketch of the graph. All right, so I'm going to have you guys try this one. We're going to end here. So take a few minutes, try to fill this out, and then we'll go over it, and that'll be the last thing that we do today. All right, so as you were doing it at your seat, I'll start filling in some of the pieces so we don't have to talk about it as much before you head out.
It's the same page we were on.
It says part 4, like under the part 4.
It's next to the problem.
I see, next.
Note to self, I totally need to add page numbers next year so that I can tell you that. This is what I came up with, so as you start to finish it up, take a peek. Those of you leaving, there's a Canvas assignment over the weekend, just take a look at that. So we're not going to add any new vocabulary in next week. Your test for this is next Friday. The only thing that we're going to add in next week is old vocabulary. So range is going to come back, which I know is like the worst of all. Increasing, decreasing behavior is going to come back. And local and absolute mins and maxes are going to come back. So we already know what those mean. We're just going to apply them to these types of problems. And you'll see that a lot of this stuff helps make that easier. All right, so that's what we're looking at next week. Your test is going to be on Friday of next week. In terms of over the weekend, there's a Canvas assignment. It's just the new vocabulary. So it's vertical asymptote, and then you fill in the blank. Just remember, when you're writing a vertical asymptote, you have to have the x equals. So it's x equals a number. Horizontal asymptote is in the blanks. X and y intercepts is in the blanks. Whole is in the new blank. So all the new vocabularies here. I gave you 3 attempts at that because I feel like if you're going to get something wrong, it's probably because you're going to type it in wrong, not because you actually don't know it. So that's going to be due Sunday night.